So, as I mentioned before, when you change your mode into parametric, you'll want to make sure if you're dealing with trig functions that you are in gradient mode when you're graphing. So when you go to your y=screen screen looks a lot different. Now you have the ability to type in the x equals and the y equals equation. So when you go back to the first page and you take a look at example 1a. Example 1a, if I want to look at this on the calculator, I can type in the 3. Now t is now where the x button is. So we have the 3x squared or 3t squared under x equals. Then you have to type in your y equals equation, which is just your 2t. Now, the trick with parametrics on the calculator, the window settings get to be a lot different. Some of you become very dependent upon the zoom button anytime you're graphing in rectangular. Now is the time where you need to get very comfortable with your window settings manually, because in calculus and with parametric and as you move forward, you have to be able, zoom is not always going to work. You're going to have to be able to set your own window settings. So what happens, if you go under graph right now, you can hit zoom as much as you want. You may get lucky. You may get something, but most of the time you won't. So you're going to have to be comfortable setting these window settings. So if you go to your window, now, just look at the parameters they're giving you. They want a T-min and a T-max. Well, look at the parameters the problem's giving you in 1A. My parameters, remember, we're going from -2 to 2. So what do you think my window T-min should be? -2. My T-max should be 2. For T-step. The T-step is really is more of the number of pixels the calculator is actually going to be graphing. The smaller your T-step, the more individual points that the calculator is actually having to calculate. So when you make your T-step really small, it will take a really long time, and I'll show you what happens as I make T-steps smaller and larger. So right now, I'll leave it as 0.13. So the smaller you make it, it's going to slow down how fast it takes the calculator to actually do the graph. All right? So now let's take a look at your x-min. So look at the table we got for 1A. What is your x-min going to be? Well, what is your smallest x value from the table or from the graph? 0. So I'm going to change my x-min to 0. X-max. What's the largest x value you got from the table? The largest x value is 12. So I'll change that x-max to 12. X scale, we're just going to plot out every 1 unit on this graph. Y-min. So now look at your graph, look at your table. What is your smallest y value? Your smallest y value is what? -4. Y-max will be 4. You wipe down, hit graph. Okay? Any questions on that? So now, as I mentioned your T-step a few minutes ago. So my T-step was 0.13. I don't know if you saw how fast it graphed it. But let's suppose I make it a little bit smaller. Let's suppose I make it a 0.07. What I mean by slowing down the graph. Not quite as fast as what it did before. So if I make it even smaller, let me change it to being 0.007. Now you can really see the direction that the curve is taking. So if you slow it down, you can see now how you can see the direction the curve is taking. All right. Any questions on that? You guys go ahead, guys, and I want you to do these. See if you can graph it on the calculator using the window settings. So go ahead and do 1B for me. Just on the calculator, I don't need you to do anywhere else.